Hi everyone, my name is Peng Cheng. You can call me David. Today I'm going to give you my presentation about planning and operational aspect of microgrids embedded within renewable and distributed energy resources. So let's begin. The first thing I'm going to show you is microgrid. So maybe once you see the word, you may get confused. What is microgrid? I just hear about microwave, but don't be worried. I will explain it to you in a simple way. So look at this picture. It's a network. It's a network. If you want to surf the internet, use your mobile phone or your laptop, you just need to connect to the to Wi-Fi. You know the Wi-Fi is provided by the hub. The hub normally in your kitchen or your living room, something else, but the hub provides the internet signal to your device. So microgrid is like a hub. Microgrid provides electricity to the user, mean like in your house. So that's the microgrid. It's small. It's small, and its safety and its efficiency. So next part is an example of the microgrid. So wind is renewable energy. The windmill is to convert the wind into the electricity, and the microgrid here is to transmit this energy to the houses. So you can see the wind sometimes is strong, sometimes it's weak. So that means the voltage from the windmill is not stable. But by microgrid, the voltage is stable and is safe to be transmitted to each house. So I think it's important to use microgrid in using the renewable energy. So here's the key points I get from my literature. The first is algorithm. So what is algorithm? Look at this picture. It's Photoshop. It's a Photoshop. So once you shoot a beautiful picture, you want to make it. You want to do some adjustment, like you want to adjust the contrast, adjust the brightness. So you just what you just need to do is to click the button or drag the toggle, and then you will make the adjustment. So why it's so easy? Because the Photoshop software has so many algorithm preset in here. So once you click the button, it means you let that kind of algorithm run. So with all these algorithm embedded in this software, all you need to do is just one tap click on the mouse. So next one is sensor. So sensor, this is a sensor. You may not believe, but it is a sensor for me because it show you the variation about the temperature. If it's getting warmer, the value getting is gained. If it's cooler, it will fall down. So it is sensor. Sensor for me is just detect the variation and give you the signal. But the signal here cannot be recognized in a computer. So what we need is a converter. Look at the picture. A beautiful girl sing a song. So I think the microphone here is a converter. Come on, let's focus on the microphone. When you sing a song, your voice is actually an audio signal. And the audio signal through the microphone, it will be converted into current. And the current will be transmitted into the speaker, and speaker converted into the voice. So that's the theory of the speaker. So this is a converter. Converter can convert the current into the digital signal. The digital signal can let computer recognize like 1, 2, 3, 0. This is our computer can read this number. And next to is management strategy and control strategy. So what's the difference between these two? I think management strategy is like a coach, and control strategy is like police officer. The coach organizes the player on the ground to organize them how to attack, how to win. But police officer arrest the suspect with his handcuff and force them to go to the prison. So I think management strategy is like the arrangement, like organize, and the control theory decide where you're going. You have to go as like enforcement. And the last is evaluation. Evaluation is like one tester testing wine. He needs to smell, he needs to check the color, and taste a little bit of the wine and tell the quality, tell the how he feels and the price of the wine. So I think that's the procedure of the evaluation. And now I'm going to show you my designing. So let's start with energy source. I think wind is one. So by detecting the speed of wind, the sensor will give response. The sensor will detect the speed change and give you the signal, but the signal is the current, so I need to go through a converter, convert it into a digital signal, and the digital signal will be transmitted to the computer. So in this part, I put the control management together because I think these two strategy can be embedded in the one software in one computer. So I think it can be done in one computer, like central processing computer. So the management decides where does the energy transform to, like to user one or user two, and control decides yes or not. You let him go or you don't let him go. And then the signal will be transmitted to the microgrid. And microgrid here we use a distributed system. So microgrid here is the distributed system, and distributed system transmit the energy to user 1, user 2, and user 3. So that's the running of my system. But if you want to maintain the running, you may need the Overwatch. So monitoring system is the Overwatch here. I gather data from the user 1, user 2, user 3, and also the distributed system. Because sorry. Sorry. So the usage of the electricity will be recorded by the monitoring system, like 30 days, 1 month. Compare the average level in January compared to the average level in February. If they are almost the same, so it means everything is okay, no problem here. But if the February is apparently higher than January, like from 100 to 200, it gotta be has some problem, like somebody stole your energy, or like the line has some problem. So that's the duty of the monitoring system. So about the whole designing, I think the advantage here is all the running is just need the computer to process. There's no need to a human being here. So I think all the processing is gonna be correct and fast. So I think efficiency is the efficiency and is the advantage here. But disadvantage here, I think you can see it's a one-way trip. It's not there's no loop, there's no recycle. So if one part has some mistake, the following part will wrong. So for example, the converter. If the converter import the wrong signal, and all the following part is wrong. If sensor put out import a very strong signal, so I may destroy the whole system. So I think this is the disadvantage of my designing. And that's the end of my presentation. Thank you for watching. I'm sorry about that because I feel sick right now. Anyway, thank you for watching my video. I'm David. See you next time. Bye.